Hello students, welcome to lesson 9 on trigonometry. I hope you are all doing well. Good. In our previous lesson, we looked at finding other trig ratios from a given trig ratio. So we solved an example and then I gave you example 2 as an assignment. I hope you've all done the assignment. Good. So let's begin our lesson today with solution to the assignment. Good. So the question says, given that 2 cos A equals root 3, find I sin A, II tan A. So we've been given 2 cos A to be what? Root 3. And then we have to find sin A and then tan A. Good. So as usual, you use the information given to draw a right angle triangle so that you find the third side. Because from cos A, you can get the adjacent and then the hypotenuse. But the opposite is not given. But we are also to find what? Sin A, which will involve what? Opposite. Okay, so we have to use this information given to draw a right angle triangle. Then we use Pythagoras Theorem to find the third side, which is not what? Given. Okay, so let's quickly do that. Good. Now, you have to also observe, now that from the cos A given, you realize that it's in a different form. It's not the usual form that we know. Okay, so you have to rearrange it for it to have the usual form that we know, because we know that cos A is always what? Adjacent over what? Hypotenuse. So we have to rearrange this form that they've given us in a form where it will be what? Adjacent over hypotenuse. So let's look at that. So from 2 cos A equals root 3. Okay, we are making cos A the subject. We want cos A to be alone. So we have to get rid of these 2. So we divide both sides by 2. So dividing this side by 2, this side by 2. This 2 will cancel this 2. We have cos A to be equal to root 3 over what? Over 2. Okay, so we use this information to draw a right angle triangle. I hope you get it. Good. So the adjacent will be what? Root 3, and then the hypotenuse will be what? 2. Right, so let's do that. So you can draw any right angle triangle of your choice. This is A. The hypotenuse is what? 2. Then the adjacent is root 3. Good. So it's left with what? The opposite. So from h squared equals o squared plus a squared. Okay, our h is what? 2. So 2 squared equals, our o is what we are looking for. Then our a is what? Root 3. So we square it. Okay, so now we are having 2 squared minus root 3 squared, which is equal to what? O squared. So 2 squared is what? 4. Root 3 squared, this square root and the square will go. So we are going to have what? 3. Okay. So we have 1 is equal to O squared. And then our O will be equal to what? Square root of 1. And on your calculator, square root of 1 is what? Is 1. Okay. So our opposite is what? Is 1. So as I've been telling you, you will get 2 values of the opposite, but because we are dealing with what? Distance, we take the positive value. So that's why our O is equal to what? Only 1. Good. Sorry. So now that we've found O, we can easily find the trig ratios that we were asked to find. So let's look at that. So our I were to find sine A. So sine A. And we know that sine is what? Opposite over hypotenuse. So from our right angle triangle, what's the opposite? We just found it to be what? 1. So 1 over, what's the hypotenuse? It's 2. So you put 2 here. So we have sine A to be what? 1 over 2. 1 over 2. And let's look at the II. We have to find tan A. So we know tan is opposite over adjacent. So what's our opposite? 1. What's our adjacent? Square root of what? Of 3. So tan A is 1 over square root of what? 3. But I told you that anytime you have a fraction where the denominator is an irrational number, that it's in a set form, you have to what? Rationalize. Okay, so we have to rationalize the denominator, and we do that by multiplying the numerator and the denominator by the value of what? The denominator. Okay, so let's do that. So from tan A equals 1 over root 3. We multiply this one by root 3 divided by this by root 3 to rationalize. So we do horizontal multiplication. We have root 3 over 3. So tan A is root 3 over 3. Tan A is root 3 over 3. So students, this is the solution to the assignment. So make sure you go over yours and you compare it with this one. Where you didn't get it, make sure you do the correction, and then next time you don't repeat the mistake that you did. I hope you are okay. Good. If you also did as I have done on the screen, then clap for yourself. You've done well. Good. So now let's move on to our topic for today. This was solution to the assignment. So let's move on to our topic for today. Good. Now we've looked at how to get trig ratio from a right angle triangle. Okay. So when we see sine theta, we know how to find. When we see cos theta, we know how to find. When we see tan theta, we know how to find it. Good. So now we want to operate on these trig ratios. Okay. So we want to perform operations on this trig ratio. We want to add sine theta to cos theta and see what we'll get. We want to divide sine theta by cos theta and see what we'll get. We want to square cos theta and see what we'll get. Okay, so we want to perform operations on these trig ratios. Okay, so we want to evaluate them. I hope you get it. Good. So our topic for today is evaluating trig ratios of acute angles. Evaluating trig ratios of acute angles. So let's see how it goes. So we have our first example. So it says, given that sine theta equals root 2 over 2, we are to find I, or evaluate I, tan theta, I, sine theta over cos theta, I, 2 over 1 plus sine theta. So let's see how to go about this question. So as usual, we've been given one of the what? Of the trig ratios. Okay, and we have to find tan theta, sine theta over cos theta, and then 2 over 1 plus sine theta. So it means that we need to find the values of these trig ratios. Okay, and then we substitute, and then we do the simplification. It's as simple as that. So it's not any humdious thing. Okay, good. So as usual, you have to use this information to draw what? A right angle or triangle. Okay, and then we use the information on the right angle triangle to find the third side, so that it will be easier to find any other trig ratio that we are asked to find. Okay, so let's do that. So before we move on, so our hypotenuse will be what? Will be 2, and then our opposite will be what? Will be root 2. Good. So solution. So we sketch our right angle triangle. This is our theta. Hypotenuse will be 2, opposite will be root 2. Okay, root 2. So we have this. So from h squared is equal to o squared plus a squared. Okay, that's the Pythagoras theorem. We are going to have 2 squared is equal to root 2 squared plus a squared. Okay, so this one will give us 2 squared minus root 2 squared, okay, equals a squared. So now we are going to get 4, because 2 squared is what? 4. Then minus this square root, and then the square will go. Okay, so we are going to have 2 equals what? A squared. So this one will give us 2 is equal to what? A squared. So our A will be equal to what? Square root of what? Of 2. So our A is square root of 2. So now we have all the sides of the right angle triangle. Okay, we have all the sides of the right angle triangle. So let's look at the I. So I were to find tan theta, and we know that tan, okay, tan is what? So tan theta is opposite over adjacent. Okay, opposite over adjacent. So substituting the values, our opposite is what? Is root 2. And then our adjacent, we just found it to be what? Root 2. So tan theta is root 2 over 2. And then this one, we just cancel out, okay? Root 2 will cancel root 2. So this will give us what? 1. So it means that our tan theta is what? Tan theta is 1. Tan theta is 1. I hope you get it. Good. So tan theta is 1. So tan is opposite over adjacent. Our opposite is what? Root 2. Our adjacent is also what? Root 2. So when we cancel out, we get what? 1. So tan theta is what? 1. Good. Now let's look at II. So with the II also, we're to find sine theta over cos theta. So sine theta over cos theta. So we just have to substitute the values of sine theta and cos theta, and then we simplify. Good. So what is sine theta? So sine theta we're given as what? Root 2 over 2. So we are going to have root 2 over 2. Then divided by, what is cos theta? So cos theta is what? K. Adjacent is root 2. Hypotenuse is what? Is also what? Is 2. So we are going to get the same value as the sine. So root 2 over 2. Now if this form is confusing you, you can rearrange it or write it this way. Root 2 over 2, okay, divided by root 2 over 2. Okay, so now they are the same thing. They will cancel out. Okay, they will cancel out. So sine theta over cos theta. I hope you are following. So if you want this form, then it's going to be root 2 over 2 times 2 over root 2. So this will cancel this will cancel this. Okay, so therefore sine theta over cos theta is equal to 1. Sine theta over cos theta is equal to 1. Now let's observe something here. What did we get for tan theta? We got 1. Okay, tan theta is what? 1. And then what have we gotten here? Sine theta over cos theta is also what? 1. So what does this imply? What does this imply? So it implies that tan theta, okay, it implies that tan theta is the same as sine theta over cos theta. So it implies that sine theta over cos theta is the same as what? Tan theta. Okay, so always, this holds, always. When you divide the sine over the cosine, you get what? The tangent. I hope you get it. Good. So that is the solution to the II. That is the solution to the II. I hope you are okay with it. Good. Good. So now it's left with the last one. The last one, which is 2 over 1 plus sine theta. 2 over 1 plus sine theta. Will you try that one for me? Okay, good. So let me give that one to you as an assignment. Let me give that one to you as an assignment. Okay, good. So we'll end here, students. We'll end here. We've solved example, the I and then the II. So I'm giving the III to you as an assignment. It's no difficult thing. You just have to follow whatever we've done so far. Then you do the same thing and your answer will come out. Okay? Good. So till we meet again, revise, read ahead. Bye.